Today we are talking about the derivatives of inverse functions. Derivatives of inverse functions. Okay, we're going to do a little bit of pre-cal algebra 2 review on how to find inverse functions, and I'm going to use that to segue into how we're going to do these problems today. Okay, so let's start with some review. We are going to review how to find inverses. And we're going to use a simple function for a simple answer, a simple way to do it. The function is y equals x squared. About as simple as you can get. Okay, how do you find the inverse of a function? What do? Switch the x and y. And solve for y. Okay. So let's do this one. So if the function is y equals x squared, it would be x equals y squared. Now how do you solve for y? Square root both sides. Y equals plus or minus the square root of x. Agreed? Okay. You do this one. Y equals 3x minus 5. You do that one. Find the inverse. Is that what you got? Something kind of like that? Okay. Something I did not do on this problem or this problem, I'm going to do it now. A lot of times when you're done switching x and y, they put a little -1 power there, and that means inverse, right? You've seen that before. So y inverse is that. Now, how hard would it be to take and find the inverse of look at that. How hard would it be to find the inverse of that? Pretty hard. Okay? But today, by the end of the lesson, you will know how to find the derivative of the inverse of that without finding the inverse of that. You follow what I'm saying? We're going to be able to find the derivative of the inverse and the inverse of this. There's a way in the back door, okay? This one's too hard to do. Okay? Now, so that was kind of a side note. We're just not even going to mess with that. What I want you to do now is I want you to graph f of x equals x squared and its inverse on the same axes. We're going to do this together. You need to go out about 4 in each direction. Now we're going to do something a little bit unusual. We're going to make a t-chart, but we're going to make it look a little different, and I'll show you why in just a second. Okay? Our function is f of x equals x squared. What is f of 1? That is 1, right? Because you plug in 1 for x and you get 1 for y. What is f of 2? 4. What is f of 3? 9. Agreed? Okay, let's plot those points. We know 0, 0, 1, 1, 2, 4. I'm not going to worry about 3, 9. There's the right side of the parabola. And then I could do more points over here. Left side of the parabola. There's the parabola. Okay. In this column, we have the square root of x. We're going to just do plus the positive square root of x for now to make life simple, because otherwise it's not going to make a pretty t-chart. Besides 0, what is the first number that I can plug in for x and get a real number, a whole number answer? 1. What is f inverse of 1? 1. What would be the next number I could plug in for x and get a whole number answer? 4 equals, and what does it equal? 2. And then what would the next one be? 9, and that would be 3. Agreed? Okay, so if you plot those, 0, 0, I just kind of skipped over. 1, 1, 4, 2 is right there. You have this, and we know that's what square root looks like. Agreed? But the true inverse is plus or minus square root, and the minus sign just flips it over the x-axis. Okay. Did you learn before this class about the fact that these two are mirror images over the line y equals x? If you draw in the line y equals x right here, they are mirror images of each other over that line. Okay. Now, what I want you to do is look at these two columns right here. What has happened to those x and y coordinates? They have flipped, haven't they? Because they are inverses of each other. So if I took some random function g and said that g of 2 is equal to 7, what could you tell me over here? G inverse of 7 equals 2. Agreed? Does that make sense to everybody? Because they're switched. So the first rule, rule number 1 for today that you need to know, is that if f of a equals b, then what? F inverse of what? B equals a. Does that make sense to you? If f of b, then f inverse of b is a. They just switch the a and the b. Okay? All right. That's where the review stops. New material starts. Okay? Because now we're going to talk about derivatives. And we didn't learn about derivatives in pre-calc. Okay? So, we're going to have now a new column that says f prime and f inverse prime. So I always put the f inverse in parentheses when I'm doing derivative, because otherwise the -1 and the prime kind of look both like, make it look like -11 if you're not careful. You see what I'm saying? Okay. Go back up here. What is the derivative of this function right here? F prime of x is 2x. Okay? I want to substitute in the exact same x values to this one. 1, 2, and 3. If I substitute in 1, what do you get? To the derivative. F prime of 1. I keep forgetting my primes. F prime 1 is 2. F prime of 2 is 4. F prime of 3 is 9. Okay? What I'm looking to see is what is going to be the pattern between these two columns. Okay? Yes?
F prime of 3 is 6.
Is 6. You're right. Thank you. My brain has been in kind of la-la land for the last couple of days. I'm still trying to work through it. Okay. F inverse prime of x equals. So in other words, come back up here. What's the derivative of this? Exactly. So I want to write this on scrap paper so I can just put a nice pretty answer right there. The square root of x is the same thing as x to the 1/2. Agreed? Derivative of that is 1/2 x to the -1/2. But where does the x really go? On the bottom. So it'd be 1/2 square root of x. Do you agree with that? So that's what I want you to write here. 1/2 square roots of x. right there. Okay? Now, over here, the x values were 1, 4, and 9. Those would be good x values to plug into this too, wouldn't they? Because I still have a radical there. Does that make sense? So we're going to do f inverse prime of 1, f inverse prime of 4, f inverse prime of 9. And I want to see how those answers compare to these answers. So take this derivative we just found, plug in 1. What do you get? When you plug 1 in here, what do you get? 1/2. When you plug in 4? 1/4. When you plug in 9, you get 1/6. Okay. What's going on here? It's the reciprocal, isn't it? So, this one was easy to take the derivative of the inverse, yes? It wasn't too hard. But if it was something like this, if I could just take the derivative of that and find its answer, all I had to do was take the reciprocal of it to find the derivative of the inverse. Does that make sense?
Could
So
you solve backwards for finding the reciprocal as finding the...
You could, but it's usually harder that way because you're usually given the original function, not the inverse. Yeah, you could. It could be done. Okay? So, let's take another step down. Let's jump all the way to 10. Okay, if I jump to 10 here, 2 times 10 would be 20, right? Now, here's the tricky question. Does 10 go here also? Do these x values match these x values? No. Can you figure out what would go here?
100.
It would be 100. How'd you get 100?
That's just that they're always squared.
It's always squared. So if I notice that when I put the original number into f, that's the number that went in here, right? So this would be 100, and this would be what? 1 over 20. Okay. That's the pattern I want you to see. So here is rule number 2 for today. And this is kind of an ugly rule, and that's why we did all this, because through the rule down, you'd look at it and go, I have no clue what that means. And here's the rule. It says that f inverse prime of f of x equals 1 over f prime of x. Whoa. That is what we just did in calculus language. The inverse's derivative at the y value is equal to 1 over the derivative at the x value. Do you see why an f of x is right here, as opposed to just an x? This is x, that's f of x. This is x, that's f of x. That's why we have to do the f of x. Okay? Now, there is a simpler way to write it. I'm going to write it down for you. So if you said that g is the inverse of f, you can write it a little simpler. It would be g prime of f of x equals 1 over f prime of x. And that looks a lot better. G prime of f of x equals 1 over f prime of x. So if instead of writing f inverse, you wrote g, you could do g prime of f of x equals 1 over f prime of x. Okay. So that is the gist of what we're doing today. And then I have a little story to tell you. 3 years ago, when I was teaching this lesson, I taught it the old-fashioned way that I've always taught it, and that's what I'm about to teach you after this, okay? And it's kind of complicated. And the day afterwards, I had a student come in to see me. Her name was Molly, and she said to me, Miss Bell, I think I've got an easier way to organize all the stuff that you're doing with this problem. And I said, really? I said, she's really smart. She had like high A's on every test. She was a really smart kid. And my jaw hit the floor because it was amazing. It was absolutely amazing. It's organized all that we're doing into a simple chart so that it's very, very simple to find the answer. So I'm going to teach you by way of using the Molly method, and that's what I call it, the Molly method for derivative inverses. Okay, Mr. Giglio's class does not do this. So if you work with somebody in her class, they're going to do a different way of writing it all down than we do. Okay? So I'm just letting you know that up front. And I think you're really going to like the way we do this. What makes it hard, though, is the fact that you don't get to see the other way to do it. And believe me, you don't want to see the other way to do it, okay? So I'm going to a new sheet of paper. Let me show you what these problems are going to look like. Okay. Now we're going to start getting very colorful because it helps to keep everything straight. F of x equals x squared. Find f inverse prime of x at x equals 16. Okay, we're taking the same function we did a minute ago, but we're going to find the derivative of the inverse without even looking at the inverse. Even though we know what it is, we're not even going to look at it. Okay? So, here's how you know to do the Molly method. It's going to say the derivative of an inverse. You've got to look for those two words in the same sentence. Whenever it says derivative of an inverse, you're going to do the Molly method. And here's how you do it. You're going to set up kind of a table. You're going to put f here and f inverse here, kind of like we did on the front.
How come it doesn't say the inverse of f?
That's what this is. It's the derivative of the inverse of f of x.
Oh.
Okay? Yeah. All right. Now, in the first row, you're going to put f parentheses and f inverse parentheses equals. So basically, the first row is for the functions themselves. The second row is going to be for the derivatives of those functions. So I'm going to write the words functions and derivatives just this first time, and after that I'm not going to write that down. So this is going to say f prime of something equals, and this one's going to say f inverse prime of something equals. Put those in parentheses. Okay. I'm going to change colors now. We're going to talk through the first one. When we do the second one, we're actually going to write the steps down that we do. Because a lot of times, like in several of the math problems, when you do the problem and then you go home and look at it 2 or 3 days later, you're like, how did I do this? You ever had that happen before? You look at a problem, you're like, I don't know what I did. I don't remember how I got all those numbers. Okay? But now I'm going to show you. I'm going to do the first one just talking, and the second one we're going to write it all down. Okay. It says find f inverse prime of x at x equals 16. That's this right here, bottom right. Do you see that it says f inverse prime of x at x equals 16? So 16 goes right there. And I want you to box afterwards because that's going to be your final answer. When we get that box filled in, we're done. Because it says find f inverse prime of x at x equals 16. So 16 goes right there. Are you with me? Okay. Now this 16, is it an x value or a y value for the inverse? Listen to my question again. Is this an x value or a y value for the inverse? It's an x value because it's in the parentheses, right? Okay, so if it is an x value for the inverse's derivative, would it also be an x value for the inverse? Go back to here. Were these x values the same as these x values?
Yeah.
Yes. So the inverse and the derivative have the same x values. Do you agree with me? So if this is an x value here, it's also an x value there. So you just move it up a parentheses.
Wait, I thought you said that was the function.
No, this is all inverse. This is the function column. This is the inverse column. So the inverse and its derivative have the same x values. Okay. Now, to move over here, we use rule number 1. If this is an x for the inverse, what is it for the original function? It's a y. Do you follow what I'm saying? If it's an x for the inverse, it's a y for the original function. So it goes outside the parentheses over here. Are you with me? Okay. So now I have a sentence that says f of something equals 16. I need to figure out what goes in here. How do I find out f of what equals 16?
Plug it in 16.
Okay, this is f, not f prime. This is f. So here's f. So do I plug in 16 or do I set it equal to 16? Set it equal to 16 because this is a y value, right? So I'm going to come down here and I'm going to say x squared equals 16. So x equals what? Plus or minus 4. Now we're going to stick with positive answers only. So I'm going to go to my green marker and say x equals 4. So 4 goes right there. because that's where x's go, right? Okay, go back over to here. If f of 4 equals 16, f inverse of 16 equals what? 4. Now, honestly, if you don't ever fill that in, that's okay. That's not one we really need, but I'm just going and telling you that's what it is. Okay, come back over here. If 4 is an x value for f, is it also an x value for f prime? Yes. So this 4 comes down there. So now this sentence says, what is f prime of 4? Can you find f prime of 4? 8. So we say f prime of x equals 2x, so f prime of 4 is 8. So 8 goes right there. So what goes in the box?
1 over 8.
1 over 8. How'd you get that?
Put it on top. I'm not really sure.
Rule number 2.
Well, we know the inverse of x squared is 1 over 2 times
Right.
pi bar.
Right. It's rule number 2. It is rule number 2. It says the derivative of the inverse is the reciprocal of the derivative of the function. So this is 1 over 8, and you are done. You are done. Okay. So all we did was write a whole bunch of numbers down, and you're going to go look at this in 24 hours and go, where did those numbers come from? I know. So we're going to write it all down here in just a minute. Okay? So let's do another one. Example. F of x equals x squared plus 4x. Find f inverse prime of x. X equals 12. So set up your chart again. F inverse. Your column headers. Then the first row is just those same letters with parentheses. The second row is the derivatives. Okay. What did we do first in the first time on the other problem that we did? Okay. So where's the 12 going to go this time? In the derivative of the inverse. So the 12 goes right there. So I'm going to write down below here, I'm going to write that the given x goes in the bottom right in the parentheses. To remind myself, okay, whatever they gave me for x goes at the bottom right inside the parentheses. And then we said it also goes where? In the parentheses?
Yeah.
Yes. In the top right in the parentheses. So if you want to write that down as well. Who can tell me why it goes there? Because they're the same x value. Whatever's an x for the derivative of the inverse is also an x for the inverse. Okay? Now, where else does it go?
Equals
The answer for f. In the top left, outside the parentheses. And who can tell me why?
because it was the inverse system. Y.
If it's the x for the inverse, it is the y for the function. Very good. Okay. Now, what are we supposed to do with that? Right. So we set the function. We set f of x equal to the outside number. So we're going to set f of x equal to the outside number. We don't plug it in. So every time I get to a stopping point, I'm changing colors, basically. So we take this function, x squared plus 4x, and we set it equal to 12. How do you solve that? No, not exactly. It has to be set equal to what? 0. So x squared plus 4x minus 12 equals 0. And we factor. How's it factor?
Plus 6, x minus.
Plus 6 and minus 2, so we get x equals negative 6, and x equals positive 2. Now, there's only one parenthesis here. So you pick the positive answer. We plug the positive answer into the top right, top left parentheses. So 2 goes there. Plug the positive answer into the top left parentheses. You can also put it over here if you want to, but you don't have to. Now, where is the other crucial place it has to go? Bottom left. Also put in the bottom left in the parentheses because it is an x value. Okay, now I got to stop and do math again, which is telling me I need to change colors. So what am I going to do? It says f prime of 2. What am I going to do?
Find the derivative.
Thank you. And I'm going to set it equal to 2 or plug in 2?
Plug in 2.
Plug in 2. So take the derivative. F prime of x equals 2x plus 4. F prime of 2 is 4 plus 4, which is 8. So that gets to be 8. I didn't realize my paper was crooked. Sorry about that. So this is the bottom left answer. And the final answer is the reciprocal of the bottom left answer. So the final answer is 1 over 8, and we're done. Okay. Do you have any questions at this point? Since we have time left, what I would like to do is to work through a couple of the homework problems with you. Okay? So what I'd like you to do now is to get out a homework paper, whatever you write your homework on, notebook paper, spiral, whatever. I'm going to hand out the worksheets, and we're going to do a few of these together. There are some that have, there are some that need a calculator, and I'm going to show you how to do those as well. We will do 1 through 10 next class. Okay. Here is the worksheet. Shh. Please listen. Here is the worksheet. Today we are doing 11 through 20 only. Tomorrow we will do 1 through 10 because it's a totally different concept. Okay? We're going to start with number 11. And we're going to kind of do it, have you do it by yourself basically. I'm going to stand here and just write, and you're going to tell me what to write down. And then I'm going to give you 12 to try by yourself because there is something unusual about 11 that you need to know. Number 11. They give me the function f of x equals x cubed plus 2x minus 1, and they give me the point at x equals 2. I'm not going to write that f inverse prime of x thing down again. So, set up your chart, f inverse, f parentheses, f inverse, oops, wrote the parentheses wrong thing. Not going to hurt. Okay, I'm not going to have you guys yell it out. I'm going to call on people today. So, dun, dun, dun. Kelly, what do I do first?
Equals 2 equal to, we'll make the f inverse prime whatever. Equal to 2.
Equal to 2 or 2 in the parentheses?
All in pieces.
In the parentheses. Very good. Equal to is what I'm looking for when I'm done. Okay? Maddie, where else does the 2 go? Above it, right there. Tyler, where else does the 2 go?
Top left hand.
Top left answer. Very good. So it goes right there. Okay? So now we're supposed to stop, and we're supposed to set this function equal to the 2. So x cubed, I don't know why I wrote f of x, x cubed plus 2x minus 1 is equal to 2. Now, that's a cubic that we cannot quote-unquote factor. And any problem on here that they say is no calculator is one that if you do a little guessing and checking, you can pretty much figure out what the answer is going to be. How many of you already see what the answer is going to be? Anybody? Pick a number and plug it in. See if you can. Does 0 work?
1 works.
Does 1 work?
No, it makes just 1. If you minus the 2 over, yeah. Yeah, you're right.
1 cubed is 1, plus 2 is 3, minus 1 is 2. So 1 does work.
Isn't it 3 squared?
Yeah, but the other 2 could be imaginary. But 1 is the one they're looking for. So 1 goes right there. Okay. Mason, where else does the 1 go?
On the opposite side of the answer.
On the opposite side in the answer. Very good. Let me see. Raquel, where else does the 1 go?
On the bottom,
Where?
inside.
Inside the parentheses on the bottom. Very good. Okay. Now it's time to do some math again. So we're supposed to take the derivative of this function, which would be 3x squared plus 2. And now, Gemma, am I supposed to plug in 1 or set it equal to 1? What do you think? Yes, ma'am, because the 1 is an x value. It goes in for 1. I don't know why I went back to my... So now we plug in 1, and we get 3 plus 2 equals 5. Goes there. And, Maggie, what's the final answer?
1/5.
1/5. Because these two are supposed to be reciprocals of each other. This isn't so bad, is it? Okay. Did we even find the inverse of this? No. But we found the derivative of the inverse at 2 without even finding the inverse. That's what's so cool about this. You're not even finding. And how hard would it be to find the inverse of that? Yuck. If you had to solve for y, it would be kind of yucky. Okay? Now, I'll tell you real quickly the old-fashioned way to do this. You switch the x and y, and then you take the derivative implicitly, and then you solve for dy dx, and then you plug in the points, and then it gets really ugly. Yeah. Okay. Now, number 12. Right now, you do number 12 yourself. All by yourself. I already know what the answer is because I did it last period. I'm going to come around and check them. And I'm not even going to write it on this paper. I'm going to have it. I have another page that's already written on. You already did it? Okay. Did y'all get 1/13?
Yes.
Here it is, done on another sheet of paper. The answer was 1 when you just guessed and checked. Took the derivative, you get 13, and so 1/13 is the answer right there. Now, number 20. This is a calculator question. Now, you can either write this at the bottom of your worksheet so you can put it on later if you're in the middle of something, or you can go ahead and put it embedded in your problems, even make your problems out of order. That's all right. Okay? And it says at x equals 3. So we're going to do f inverse, f okay. Give you a chance to write that down real quick. Gotta hurry. Where do I start? What goes where? 3 goes bottom right there. And it goes top right there. And it goes right there. Now, here's where it gets yucky. I'm supposed to set this equal to 3. So I'm doing x e to the cosine of x equals 3. Now, my calculator already has it in there. You go to y equals, and you type in x e to the cosine x and y1, type 3 into y2, and set your window. Now, it's probably going to be a small number, So I set my x's from -5 to 5, and the y's, I'm going to do -5 to 5 also. It has to at least include the 3, agreed? Okay, so if you graph that, that's what you see.
Are we supposed to put in the 1 and 1?
The left side of the equation. Okay? Now, I need to now find that intersection point because that's the point I'm looking for. So second, trace, oops, I did the wrong thing. Second, hang on a minute. Second trace intersect, it's already there. You would have to scroll, push enter 3 times, and you get this decimal. So that decimal is your x that goes right here, 4.335, and down here, and over here, if you want to put it in all 3 places. Okay? Now, here is the really cool thing about this. Okay? What am I supposed to do next? Take the derivative of this and plug in that number. Okay? How do you take the derivative of this? Product rule and chain rule both. So watch this. The derivative will be 1x times d2. How do you take the derivative of e to the cosine of x?
Negative sine x.
E to the cosine of x times negative sine x. It's copy paste, then times the derivative of the power. Plus second, which is e to the cosine of x, times the derivative of the first, which is 1. Now, here's the beauty of the calculator. After you do some sort of an action right here, an intersect, max, min, whatever, the calculator now thinks that this number is x. Okay, do you see what that decimal is? Watch this. If I just type an x right there, that's the same decimal. So all I have to do is type in this derivative that I just found using x's for the x's, and it'll automatically substitute them in for me. It's kind of cool. So x e to the cosine of x, parentheses, negative sine of x, close twice, plus e to the cosine of x. Done. There's your answer. Isn't that cool? 3.481 is what goes here, 3.481. And so the final answer you can leave as an ugly decimal, 1 over 3.481, or you could do 1 divided by second answer, but you can't see what I'm doing. Do 1 divided by answer, and there is the exact answer, which is 0.287. Okay? So did you follow how I just took that x over, typed it in, got my answer? Really makes life beautiful. Okay? Your assignment is just to finish these 11 through 20. And we're ready to go to the new material tomorrow.